Hey, I'm just going to quickly take you through some of the... well, actually, this video is going to focus purely on networking and the door and button implementations I've done. So, I barely wrote any code to get... Well, I wrote a little bit of code to get the networking working. I've implemented it for the pawn mesh I had. So I've got a player controller that can run around and jump. And that is actually networked on a server. And let me just swap windows, Microsoft, hit join, there we go. So you can see here, if I look at the other character and I jump, and then I swap characters, and I jump, swap again, and jump. See, it works. Now, if this person looks to the left, and I go over, and I press this button, the door opens on both clients in sync. This is because I've networked the inputs of the player to the world. So I can go through, and now the other player can come and they can lock me out. They can say, no, you're not allowed in here. Go away. And then that was actually really easy. Well, the world's slowest closing door. And that was actually really easy to implement thanks to the mapping tool. Now I'm going to show you how this works. You can, let me just open this door up again. So we're going to go over to this ramp area because I've also added a button there, pressure plate. Let's call it pressure plate for now. I don't really count it as a button. It's a pressure plate and it opens the door. This could be interesting because it could allow me to make a co-op like element, like one of the players has to open the door for the other player when they get to the exit. So now I've got networking, it makes loops like that very easy to add. Player's trapped, oh no, let me out. Or vice versa, it could be the other way around. Maybe the other player spawned in here and you have to release them. But this is buttery smooth for me. I really am happy with the library. It's called Netfox. Please excuse the character mesh. I'm still trying to decide on whether I use this library. So that's for another video. So let me quickly explain how Netfox works. First up, you add the plugins, extras, internals, no array, Netfox. And you add some globals. I had to add async because I stole some of the example code. I went to their GitHub project, I extracted their example code, and I improved their extras plugin so that it comes with a bunch more things. So the thing I stole out of one of their example projects was, or used from the open source repo, was that they had this user interface for setting up your debug game. So they have this, this address localhost window that had been pre-done. So I thought there's no point in redoing a bunch of effort when they've already done it for me. So I used that and reused their code because it doesn't make sense to write anything twice just because of ownership. Especially with MIT licensed code, it doesn't make any commercial sense to do that. So now I'm going to go down to the player class and, well, the world, and explain how the world is set up with Netfox. So Netfox uses a object called a player spawner, which actually can be written by you. And you hook into some network events to spawn and remove the player. Initially when you spawn, you set the player's multiplayer authority to the server, because that's how this works. Then your player spawner has a node on it to say what the player scene is. So then we'll open this up. Every player needs a rollback synchronizer, a tick interpolator, and an input class. Your input class, what it does is it decouples your inputs. Right, let me simplify this down a bit more. What it means is one file reads the inputs of your game, and it reads the inputs of your game, and then it supplies them to your player controller, and then when the rollback synchronizer is set up, what it will do is it will unwind the state. So for example, you see the input properties here? Rollback synchronizer has a couple of settings. So it's got state properties, which is saying, okay, the game state is for the player is a transform, the player velocity, the speed, the current animation state, whether I'm low to the ceiling, whether I was on the floor, and what my head rotation is for your facing direction. And this is enough to network the player's game state. The next bit you add is the actual inputs for the player. So this input class is saying, hey, in my input class, I use input direction, jump, sprint, crouch, mouse input, just press for sprint, crouch, and pause, just press. And these are basically just my control states. So what happens in this network library, in this networking library internally, is it replays what inputs you press on the other client to network it. So it takes this data and sends it to your other client and replays it. And what the library does is it predicts what you're going to do based on what your action was. So if you were walking forward, it'll assume that you were walking forward on the other. It will assume you kept walking forward on the other client, and then if you didn't, it'll send the rollback, undo it, and then redo the correct state. So it'll take the state property and says, "Hey, your transform's out. Okay, I'm going to set it," and it'll work out what it needs to interpolate to get you on the correct state, by applying a small bump in the right direction rather than anything crazy like you would see in certain games that I've played recently. They don't have any rollback and the networking is just terrible. Whereas in 4 hours I managed to get rollback working in this game, which isn't an impressive thing from my perspective, something I did. This is something impressive that this library did. This Netfox library abstracted away the nitty-gritty, annoying tasks that I don't want to do again and again and again for every project I work on. So thank you very much to the Netfox author. You've done a great job. Right, now back on to the basic networking. So rollback synchronizer is synchronizing these properties for the player, and I had to modify the player class to just basically supplement all the input values to be part of, let me say that again, all the variables like input dot get button pressed had to be removed from this file and put in my input class so that my rollback synchronizer could read from input and not from the player networked. And then my player controller then had to read those inputs from the input class instead. So it says input node dot player input. So it says, hey, my input class, get me that, and then read the variable directly from there. So basically, there's no input dot get button pressed in your controller by design. That's so it can rewind the state. The other change that you have to make is move and slide doesn't work correctly without doing this. So what this does is this removes the this multiplies the physics factor by the velocity to make the move and slide behave deterministically with the network time. Now I don't want to go too deep into this, but basically move and slide is already delta compensated. What this does is it takes out the delta compensation and then it adds its own compensation based on what the actual network lag is and stuff. So it calculates a physics factor based on those things rather than based on your frame delta, which would cause inaccuracies. Still uses the delta, but it uses its own variation of said delta, and as you saw when I was using it, it gives you a smooth result. Now let's quickly show you how to do a button from scratch and then we'll call it on this video. So let's make an elevator. Yeah, let's cut a hole in the wall. Yeah, we're gonna make an elevator and an objective. Doop. And as I showed in the previous video, I'm just gonna do CSG subtract. Right. And I'm going to go to the top down view. This is why this tool is so powerful. You know, all the geometries essentially detached. That's why I always compared it to a CAD program. Right, and look, when you make mistakes, unlike a modeling tool, it's forgiving. And when you're feeling lazy, you know, there are days where you just don't want to do something. That's okay. You can just be like, oh sure, let's just add a ramp there. No one will know. See? No one knows. Alright, so we're gonna make this our little elevator. And this is gonna be a mover. Because it moves. Dun dun dun. And if I remember correctly, this moves up 10. So this is going to do the very same thing. We're gonna put it down first. How much does it need to move up by? So 120, 136. 136. Remember that number. I'm assuming that's the units. It might be 136 meters knowing Godot. So, well, we'll just leave it that value and we'll hope it's right. Right, and we're gonna put a... how should we do this? It's an elevator. So we'll put a little button here. We'll call this elevator. That's our name. And then we're going to add a button. I'm sure you Quake mappers who are watching my video are like, oh my god, he doesn't know how all the shortcuts. Don't worry, I'll learn all the shortcuts eventually. Just today's not the day. Right, let's just do it this way. Oh, I also need to change my grid size. That would probably help a lot. Yeah. Wondered why it kept doing that. So we'll just put a button on the floor. There we go. We're going to change the class of this. Like I mentioned in the last video, there's classes. Classes let you do custom behaviors in the game. So the game says, hey, here, map editor, I have these classes. Here they are. Here's the properties that they have. Which is quite cool. So we have buttons defined by the library, which is great. I'm assuming that it's going to be on the negative y-axis. I have no idea if it will do that for sure. So what we're gonna do is we are going to check the room. You can obviously see it's not been reloaded yet. We're gonna go here and we're gonna do full build. Unwrap the UVs, and then we're going to probably bake the world map. So let's add some lights as well. I can show you that real quick. So the way you add lights is you right click, you add a point entity, that's it. And we've got one in this room. We're gonna duplicate it in 2 seconds once I fucking, excuse my language, once I can grab it. I swear I didn't swear. Sorry, it's my Scottish nature, I do apologize. Cussing's bad. Right. There we go. Excellent. So we've got some lights, and now we're gonna reload our scene again. Boop. That'll do. There's some basic lighting in there. And in here there's some basic lighting. light map GI. I don't know if I even set them to static. They should be static by default. Oh, it's set to ultra. Oh, we'll be waiting a while. Sorry. This is a moment where you need to go grab a coffee. Or I could pause the recording for you. Or I could make you suffer with me. I'll be nice. Okay, I'm back. Sorry about the delay. Right, so let's play our map now that we've built all the lighting. And yes, it's 3 AM. Woke up quite early last night. I went to bed and just woke up at like midnight. So just did a little bit of game development today. The lighting looks exquisite. I do not regret building it. So you can see here. Oh, our mover class is doing nothing. Oh, I know why. I didn't link it. So these have targets. And we'll tell it. What the hell? Oh, it moved the class up. Okay, I didn't see it because it was so fast. Right, so and we're gonna full build again. It shouldn't throw our lighting off. It might. Do I need to unwrap UV2? Yes, just in case. It shouldn't have any different geometry, so it should still work with the existing light map. Famous last words. Right, so I think we'll just focus on one client right now. Oh, good God. Space shuttle status confirmed. So as you can see, the elevator might kill you and cause the G-forces to, you know, hurt. So I don't know what the unit scale is here. I'm assuming this is in meters, so we 5 meters actually. We'll do 5. Okay. Wait, 1, 2, 3, 4. Maybe it is. We'll do 6 meters. Okay. Nah, we'll do 7 because I accidentally typed that in. Lol. This is precision. Probably need to do a video on when I work out the numerical scale differences between Godot and this. Oh, another thing I fixed was the materials. I actually found how to, thanks to a YouTuber, they commented that you can just name the material. In the last video, basically, I struggled with the textures being just the PNGs. So a viewer pointed out that I can just literally put the material file in the same textures directory and it'll pull the material instead of pulling the PNG texture, which meant I could set up my materials in advance. I really appreciate that simple piece of advice. Thank you so much. So anyway, I don't think I hit full build. Unwrap, run. So anyway, what we're gonna do is we're gonna get this working and then we're gonna call it. That is almost the right height. So I'd actually say it's about 10. So 10 was actually a good number there. And then, right, so I've noticed that there's no delay. So the nice thing about the buttons is they have a delay. So we'll add a press signal delay and a release signal delay. That doesn't really matter in the case of the object that we're dealing with. And I probably should have hit the full build and unwrap. Honestly, I'm going to set this up so that that just automatically gets pressed when the file changes. Anyway, there we go. Well, so much for the delays. Alright, I'm going to have to be smart about this. I'm tired, so being smart is not going to work. Okay, since the delay is broken. What's the difference between trigger and press? Ah, I guess I can, this is the time to show you how this works. So, there are classes declared for the map editor to use, the map into Godot. And basically, these classes define how the map editor and Godot hook up together. And it's really straightforward how it works. In fact, I feel like you should look at the code examples yourself because it's so straightforward. So, by the looks of things, press is what we're looking for. So we want trigger signal delay. Yeah, I was right. So it's maybe the docs is slightly wrong here. At least the way it's written is slightly confusing. Anyway, this should add a 4-second delay to the elevator ride before we get on. No. Oh yeah, it does help if you build your map. This is what happens when you do things at 3 AM. So, full build, unwrap, run. Host. Nice. Oh, physics engine, yay! I got thrown out of the wall. Let's see if I can make it this time. Wow, that actually perfectly lines up with the hole. There we go. So we made it into our new room. So you can see how these mover classes could be used for making elevators or for making doors. I think they're fairly universal. I think the physics engine is very ubiquitous at making me get stuck in things as well, so I'm going to need to fix that. I'm going to just swap in Jolt tomorrow. And anyway, I hope you liked this video. I know it was a bit long, and but I hope it's helpful to sort of show how well this translates to Godot, and you know how easy it is now to make multiplayer first-person shooter games in Godot. Just using some libraries. Obviously, I didn't explain absolutely everything, but I did go over the high level, and honestly, the high level is all you need. The rest you can do yourself from reading the documentation, from checking the Netfox docs and the examples. The examples are great. They've done a great job. So anyway, thank you, and I hope you liked the video. Please like and subscribe. Thank you. And it's really good to actually have people watching my YouTube videos. I really appreciate you as a viewer, so thank you.